We've learnt what astrobiology is. It's always very useful in science if you want to get some perspective to understand the history, because the history of a subject can tell you how you've got to the place you're at the moment and what it was that led to the state of knowledge that we have today. So let's look at the history of astrobiology and get an overview of some of the early thoughts in this field and how it is that we've come to the state of knowledge that we understand about the possibilities of life beyond Earth today and our understandings of the history and evolution of life on Earth. You'll often hear people say, astrobiology is a very new science, an emerging science. It's certainly true to say that astrobiology has developed very rapidly in recent years, and the experimental methods that are now being developed, new missions and new telescopes, are making this a subject that's advancing at a remarkable rate. But it's certainly not a new science. People have been contemplating the possibility of habitable worlds for a long time. This is a really rather remarkable statement by Metrodorus, an ancient Greek philosopher who was actually a student of Democritus, who first proposed the atomic theory of matter. And this is, in loose translation, what he said. He said, "It would be strange if a single ear of corn grew in a large plain, or there were only one habitable world in the infinite." Metrodorus was expressing the idea that if you go into a field, it's very unusual to see one ear of corn growing in the middle of a field with no other corn around it. Generally, if you go into a field and you see corn, you'll see a lot of it. And he wondered, if there is life on this planet, then surely there must be other worlds with life as well. Well, the ancient Greeks didn't quite have the same perception as the heavens that we do. They didn't understand about planets, and they didn't understand what the nature was of other stars. But nevertheless, this was a remarkable statement for people thinking in the early years of astrobiology over 2,000 years ago about the possibility of inhabited worlds. As we go on through history, we find other speculations that are just as remarkable. In the 16th century, during the Renaissance, this was a statement made by Giordano Bruno, who was an astronomer speculating about the possibility of planets beyond Earth. And it's worth reading what he said. He said, "In space there are countless constellations, suns and planets. We see only the suns because they give light. The planets remain invisible for they are small and dark. There are also numberless Earths circling around their suns." Now, if you think about this statement today, in an age where we are beginning to detect Earth-like planets around other stars, this is a truly remarkable speculation for the 16th century. I'm not a great fan of calling people fathers or mothers of particular fields of science. I don't think it does good things for the human ego. But if you really want a father of astrobiology, you would probably give it to Giordano Bruno, a person who speculated on the presence of other Earths orbiting other stars in the 16th century. Bruno, unfortunately, was burnt at the stake in 1600, not just for his astrobiological speculations. He did other things that incurred the wrath of his religious superiors. But he was the first astrobiologist, at least, to meet his fate, speculating, amongst other things, about life beyond Earth. The invention of the telescope allowed us to go beyond these speculations, to see planets around other stars and to start to form more empirical ideas about whether other planetary bodies could sustain life. And you might think that once the telescope had been invented, there would be a lot less speculation, because now we'd have real data about other planetary bodies on which we could base ideas and speculations. But in fact, remarkably, completely the opposite happens. Now we have telescopes, we can see other planetary bodies, but we don't have enough information to know what their environments are like. So now we've got all these new planets on which we can speculate about the presence of other life. And the invention of the telescope by Galileo, and you can see here one of the first images that he looked at, which was the moons of Jupiter, the 4 largest moons of Jupiter, now called the Galilean moons of Jupiter. This invention of the telescope and its widespread use led to the discovery of planets that caused speculation to run riot during the Enlightenment. This is a speculation by the famous scientist William Herschel, who wrote, whilst observing the moon, "By reflecting a little on this subject, I am almost convinced that those numberless small circuses we see on the moon are the works of the Lunarians and may be called their towns." Herschel was observing asteroid craters on the moon, craters that seemed almost perfectly circular, so circular they couldn't possibly have been formed by natural processes. They must be the work of an intelligence, and he believed that the moon might be inhabited by lunarians who were constructing these fortifications on the moon. And even Christian Huygens, famous astronomer, observed spots on Venus, Mars and Jupiter, spots that we now know are features of storms and deserts on the surface of Mars. And he concluded there were clouds and water, and he stated, "The taste of music with the inhabitants of Venus and Jupiter is at a high level, similar to that of Frenchmen or Italians." Now, these observations today seem crazy to us, and they seem crazy particularly because they came from extremely erudite scientists that achieved remarkable things in their field. But it shows how, with a very limited set of data, people began speculating about life on other planets. And I should say that these speculations are also a warning from the past, a warning about being too optimistic in astrobiology. And we should be careful today in learning the lessons from our forebears about over-speculation with very little data. Even in the 20th century, speculation runs riot. Percival Lowell, an astronomer who observed lines across the surface of Mars, an optical processing trick of the human brain, which he interpreted to be canals built by a desiccated, dying civilization on Mars, trying to channel water from the polar ice caps to the equatorial regions of Mars. And he observed these canals over and over again, and so convinced was he wrote this: "Every opposition has added to the assurance that the canals are artificial, both by disclosing their peculiarities better and better and by removing generic doubts as to the planet's habitability." The first person really to connect habitability with intelligence on a planet in our own solar system. We now know, of course, there are no canals on Mars. Percival Lowell was deluded by his observations, but it shows that even in the 20th century, people thought there might be intelligences on other planets in our solar system. Aliens still grip the human imagination. You only have to watch films produced by Hollywood and other production companies around the world. Aliens are pervasive throughout popular culture, from Star Wars to the extraterrestrial to the War of the Worlds, and on it goes, a long list of aliens that we've seen in films. So you can see how optimism about astrobiology and particularly intelligent life still grips the human imagination, and we have to be very careful to separate what our imagination wants us to believe and what the data, what the knowledge that we have from telescopes and missions is really telling us. That's a very important lesson in astrobiology and indeed in any science. In the 1950s and early 1960s, the space age began to unfold, and with it the possibility of sending spacecraft to other planets. And we started to get views from spacecraft orbiting Mars and Venus, and these views were rather depressing. On the left-hand side there you can see an image from Mariner 4 from 1965, and Mars looks like a dead desert. There's no obvious canals there, no intelligent civilizations. And on the right you can see an image taken by the Soviet Venera spacecraft that landed on the surface of Venus. And again, no Venusians playing music like Frenchmen or Italians, just a dead planetary surface. And these visions of our solar system really caused, I would say, almost a sense of depression even amongst scientists during that period about the possibility of life throughout our solar system. No evidence for civilizations, not even any evidence for simple life forms, even microbial life on these planets. And so the early years of the space age were a period where people began to backtrack in their optimism about life beyond Earth. But ironically, as these spacecraft improved and as our cameras improved, we began to see details that suggested that we might not be quite as negative as we thought we needed to be in the early years of the space age. People began to see valley networks on the surface of Mars, outflow channels that suggest liquid water on the early surface of that planet. And now we know quite conclusively that there was much more abundant liquid water on the surface of Mars early in its history. And as we saw earlier in this course, liquid water is necessary for life as we know it. So the presence of liquid water on the early history of Mars, suggests that this is a planet that may have been habitable for life. This is a remarkable image of Jezero crater on Mars, and you can see an ancient Martian river flowing out into a crater, and these deposits that are essentially deposits of sediments in a delta. This is an ancient lake on the surface of Mars. Could it have harboured life? Well, this is one of the questions that we're looking at. But as the space age developed, so astrobiology has moved into perhaps a more optimistic stage of considering the possibility of life beyond Earth. What were the other developments that allowed astrobiology to make the transition from a philosophical and speculative science in ancient Greece and in the Renaissance to an empirical science constrained by data? Well, let's have a look at some of these early developments, and possibly one of the most important experiments was one conducted in 1952 by the scientists Urey and Miller, who were interested in the origin of life, and they carried out an experiment to simulate an early Earth atmosphere. And you can see this rather ingenious apparatus where they've got some water boiling away inside a flask, being circulated into another container that's got an electrical discharge apparatus. And this electrical discharge is discharging across an ancient simulated Earth atmosphere. And they circulated this water round and round, and after a period of time, they found that the gases in this container, once they had been electrically sparked, transformed themselves into amino acids that we saw are the building blocks of life. So in this simple experiment, using only water and the constituents of early Earth atmosphere, these scientists managed to create the building blocks of life. This was a truly remarkable experiment, a breakthrough in astrobiology that allowed scientists to go from speculation about the origin of life to thinking about how those early building blocks might well have formed. Nowadays, we think that the atmosphere of early Earth is actually slightly different from the atmosphere that was used by Urey and Miller in their early experiments. But nevertheless, this remains a remarkable and landmark experiment in the early history of astrobiology, at least in the 20th century, and taking our understanding of the origin of life to a new empirical level. Alongside these sorts of studies, people were beginning to study the early rock record on the Earth to try and find evidence for early life on Earth, collecting rocks, breaking them open, and trying to see whether there was life. These are some images of ancient microfossils from the apex chert, which is a type of ancient rock found in Australia, well over 3.5 billion years old. And these are purportedly the microfossils, fossils of the earliest life forms on Earth. Well, these fossils are highly controversial, and many scientists argue about the nature of different types of fossils in the rock record. Are they biological? Are they produced by chemical processes? And we'll look in a bit more detail at that in a future lecture. But these early studies of fossils in the rock record were pivotal in beginning to take, again, our understanding of the early evolution of life on Earth to a new scientific level, where we could start to argue about evidence for fossils in the rock record, an argument that continues vigorously today. And other experiments were also taking astrobiology into new territory, scientific territory. We looked at some of the early evidence for the lack of civilizations on Mars. Well, by the 1970s, we were able to send spacecraft to the surface of Mars. And the Viking 1 and 2 landers, which are shown here, carried out the first biological experiments on the surface of Mars to search for life. Their results were inconclusive. And again, these are highly controversial results that many scientists continue to argue about today. Did Viking 1 or 2 find life, or did they not? Well, these experiments will be backed up or not supported, as the case may be, by the Mars Science Laboratory and other rovers and missions that will travel to Mars in the future. But the Viking 1 and 2 missions to Mars in the mid-1970s, again, were a breakthrough in astrobiology because they were the first real experiments, the first empirical experiments to search for life on the surface of another world. And they took astrobiology from early speculations to new experimental discoveries. Other very interesting experiments occurring even in the 1970s. The first signal was sent out to alien intelligences from the Arecibo Dish Observatory in Puerto Rico. And you can see the image of the message that was sent out into space here. It was sent out in binary code, and it included lots of information, such as, for example, a diagram of DNA, the information storage system of life, a diagram of a human being, a map of our solar system, and even the numbers 1 to 10. Well, This message was very short, and it probably will not be picked up by an alien intelligence, but nevertheless the first experimental attempt to communicate with alien intelligences, a new and remarkable experiment in the search for and communication with extraterrestrial intelligence. In very recent times, we've seen new experiments to study the environments of other planets and see whether they might be capable of supporting life. These images sent back by the Mars Science Laboratory of ancient rivers and ancient riverbeds on Mars, conglomerated rocks that are believed to have formed by flowing water at the bottom of rivers on Mars over 3 billion years ago. Evidence that there was liquid water on Mars, and evidence that these are the sorts of places where we might try and search for evidence of life, or at least see whether these environments were habitable. And beyond Mars, in the last 2 decades, other extraordinary discoveries that are taking astrobiology into new realms and new locations to search for life. This incredible image is of Enceladus, a tiny moon of the planet Saturn. And there's evidence that there are geysers erupting from the south pole of this moon, throwing out water and other elements into space, including organic carbon. The Cassini spacecraft that flew through these plumes discovered different elements like silicates, sodium, water, also methane and complex organic carbon. Is Enceladus a location for life? Well, at the moment we don't know, but this is certainly a very promising target for astrobiologists to explore in the future, and might be one of the best places to study early chemical reactions that might have been responsible for the origin of life, or even to search for life itself. Other moons have been discovered that are covered in interesting chemistry. This is the moon Titan, another moon of Saturn. The Huygens probe landed on the surface of Titan a few years ago and took these images, showing the surface of Titan covered in these rocks. These rocks are actually made of ice, icy water. But they're in an environment that's very different from one that you and I may be familiar with. Here, the rivers are made of liquid methane and other types of hydrocarbons like ethane. This is an alien world, but an alien world full of organic chemistry, which might tell us something about the early evolution of life on the Earth and how organic chemistry gives rise to the building blocks for life. This is a promising location for astrobiologists to understand the chemistry that's necessary for early pre-biology. And I think it's true to say, and this is not an exaggeration, but the most extraordinary development in astrobiology over the last 2 decades has been the search for planets around other stars, and particularly recent searches for Earth-like planets around other stars. This is one of the holy grails, if you like, of astrobiology, to find a second Earth orbiting another star. In recent years, most of the planets that have been discovered are too hot, they're too close to their star, or they're too large, they're gas giant planets that don't have rocky surfaces necessary, we think, for life. But in the last couple of years, planets are being discovered around other stars the size of the Earth or slightly larger than the Earth that may have conditions suitable for life. The search for Earth-like planets around other stars is surely one of the most incredible developments in astrobiology in recent years, and one of the most extraordinary vindications of that early speculation by Giordano Bruno about the possibility of numberless Earths orbiting other stars. So what have we learned in this lecture? We've learned that despite everything we hear about astrobiology being a new science, it's actually an ancient science that began in the philosophical schools of ancient Greece. It's only recently it's become very scientifically constrained with new missions and spacecraft that have allowed us to study the surfaces of other planets, and new studies of ancient rocks that have allowed us to study the possibilities of early life on Earth and how life first originated on our planet. We've also learned there are several planetary bodies in our solar system that have become of interest in the search for life and will be explored in future years. We can now hunt for Earth-like planets around other stars in our galaxy, opening up vast realms of space to astrobiologists to search for life and study whether the experiment in biological evolution that has occurred on the Earth may have occurred somewhere else. I think we can say without a shadow of doubt that the future will hold many remarkable discoveries and surprises in this rapidly developing field of astrobiology.